Alright, so today we're going to be looking at the question here. A buffer solution is prepared by mixing 51.5 milliliters of 0.142 moles of sodium dihydrogen citrate with 56.5 milliliters of 0.579 moles of sodium hydrogen citrate. Calculate the pH. We're given our pKa value of 4.77, and that's associated with sodium dihydrogen citrate. So right away, we know that sodium dihydrogen citrate is going to be our weak acid, and sodium hydrogen citrate is going to be our conjugate base. So here's the question. I'm going to leave it in the description below, but if you guys want to copy it down and follow step by step the process of getting this answer, go right ahead. So pause the video and copy it down. So step by step here. So what I like to do is write down everything we know. So we have our sodium dihydrogen citrate, and it has a total volume of 0.0515 liters and a molarity of 0.142 moles per liter. We're going to have our sodium hydrogen citrate, which is going to have a total volume of 0.0565 liters and a molarity of 0.579 moles per liter. We have a pKa value, and that's associated with dihydrogen. So pKa equals 4.77. Okay, so this does look like a complicated question, and it's not really if you know the steps, and the steps are pretty easy. They're just basic calculations. So, step number one, we are going to take each of our sodium dihydrogen citrate and our sodium hydrogen citrate. So first we'll do sodium hydrogen citrate first. So sodium hydrogen citrate. We're going to take our volume, 0.0565 liters, and multiply it by our molarity, 0.579 moles per liter. And that's going to give us 0.0327. Okay, we're going to do the same thing for sodium dihydrogen citrate. Sodium dihydrogen citrate equals 0.0515 multiplied by 0.142 moles per liter. And that's going to give us 0.0073. Sorry, I forgot the units here. Moles per liter squared. Moles per liter squared. Now that does look like an odd unit, moles per liter squared, but that's okay, because later we're going to be dividing by liters to get moles per liter. So, going to step number 2 here, we're going to take these answers calculated above, and we're going to divide it by our total volume. So again, we'll just do this. Sodium hydrogen citrate equals, so you're going to take this number that we found, 0.0327 moles per liter squared, divided by the total volume of the 2. So what's the total volume of the 2? 0.0515 liters plus 0.0565 liters, which gives us a total of 0.108 liters. So back down here, we're going to go divided by 0.108 liters. Liters cancel. We're left with moles per liter. And we're given 0.302 moles per liter. We're going to do the same thing for sodium dihydrogen citrate. And we're given 0.0073 moles per liter squared divided by 0.108 liters. Liters once again cancel. And we're left with 0.0677 moles per liter. Okay, so this one here is going to be our conjugate base, and this one is our conjugate acid, and we know that because our pKa value was given for the dihydrogen citrate, and we also know that because you're losing your hydrogen. Okay, so now all you have to do is plug it into the equation, which is pH equals your pKa value plus log of your base over your acid. Or you can say this is your conjugate base over your conjugate acid. So this is going to equal 4.77 plus log of our conjugate base 0.302 divided by 0.677, which is going to give us 4.77 plus log 4.47. After calculating this, you're going to get your pH equals 5.42. Done. So quickly going over the steps again. You're going to want to find your total volume in liters. Step number 2 is you're going to take each solution that you have. You're going to multiply your volume by your molarity. After that, you're going to take your molarity that you found and divide it by the total volume because you are mixing these solutions. After getting those values, which was these two here, you're going to plug it into your equation here. And that's really it. If you guys have any questions, feel free to leave them in the comment section below, and I'll try to get back to you. Thank you guys very much for watching.